in this calculation we are calculating the delta. We are calculating the delta wk, which is the derivative of error with respect to the weight. We are taking the weight k. So here if you observe, there is the x input and we are adding the w, that is the weight, and that is calculating the y, and that is going for the error calculation, that is E. Now what we have to do is we have to find the derivative of E with respect to W. That is what we are doing in this. Now in this, as we have discussed the derivation part, we are applying the E here and then we are applying, and this term is involving the W term. So because of that reason, we have to calculate the derivative for this, so that we are calculating the derivative of y with respect to w, we are calculating, so that we are getting this output. So this complete concept is called the delta rule. We are calculating the derivative of, that is also called the gradient for the error with respect to that particular weight. So that for each weight we have to calculate this. After calculation of the gradients, based on this gradient, we have to multiply the gradient with the learning rate, that is epsilon here, and we have to apply this on the weight. Now let us see the another kind of neuron, that is, this is for the linear neuron. This is not for the all types of neurons. This is for the linear neuron only, because we are taking y equal to w1 x1 plus w2 x2 plus w3 x3 only. Now we are going for the another kind of neurons also available. For the another kind of neuron, that is a sigmoidal neuron. For the sigmoidal neuron, we are taking whatever we have taken the y in the previous case, that we are taking that as a z here. Z equal to sigma wx, so that we are going with the wx, sigma wx, and y equal to 1 by 1 plus e power minus z. Here this will be applied here, right? Now we have to calculate for this also. What we have actually we have x and we have the w. From the w we are calculating the z. From z we are calculating y. From y we will go with e. So we have one more step, that is this step 1 by 1 plus e power minus z. This is the additional step involved in our derivation. So how it will affect? Now for the basic rule, dou z by dou w, which is equal to x k. Why? Because it is involving the this is involving whatever is involving the w, that w only will remain, and the related to the w, what is the multiplication of that w, that will remain, so that xk only remains, remaining will be nullified with 0. And dou j by dou xk, dou z by dou xk with respect to x, if you are doing, then x term, all the terms which are involving other x other than k terms of x, they will be 0, and only wk xk will remain, and with respect to xk we are derivating, so that we will get only wk. Okay, this is the basic rules, basic formulas. And now we have to calculate now dou y by dou z. First we are calculating this, because it involves so many things. What we have to calculate? dou E by dou W. Our intention is we have to calculate dou E by dou W. This is what our intention. But here we are calculating dou Y by dou Z. This is having e power z by 1 plus e power minus z square. How it is coming? For that we have to analyze this. Dou y hat, here I have taken y hat, y or y hat, you can take that. So dou y hat by dou z, I am taking this, and whatever we are having in the place of y, we have to take 1 by 1 minus e power minus z. Instead of 1 by 1 plus e power minus z, I am taking that as inverse. So 1 plus e power minus z whole power 1. So I am replacing that with this. Now let us take 1 plus e power minus z as u, and now our equation, this equation will become, this is taking as the u, so that will be taken as dou u inverse by dou u into dou u by dou z. This is the chain rule, meaning that whatever you are applying the thing, in which term, with respect to what you are applying, for that you have to derive separately. This is the chain rule. By applying the chain rule, dou u minus u inverse, here in this place we are applying u, dou u inverse by dou u by dou z. Actually we have to apply dou u inverse by dou z. So for that we are applying dou u inverse by dou u by dou z. And now dou u inverse by dou u, that will become as minus u power minus 2. How it becomes? It is, see here, with respect to u we are deriving, so that you can apply this u. Now whatever is there in the exponential, that will come here, this will come here, so that minus 1 into, so minus 1 into means minus, and in the exponential it will decrease 1. Already there is minus 1, so it is taking minus 2. It is becoming minus 2. So dou inverse, that is the minus u power minus 2. And now dou u by dou z, we have to calculate, that is dou by dou z of 1 plus e power minus z. We are substituting whatever we have taken. So that is equal to, here only dou z, e power minus z is having the term z, so this will be cancelled. E power minus z, it is having the minus on the top, so that it will come down into minus, come down into this, and it will become as the z, so that minus e power z will be given. Now we have to substitute these two in our formula, so that dou y hat by dou z equal to minus u square. So whatever we have given this, in this we are applying into e power this. And now for this, what is u here? What is u here? U means again 1 plus e power z, e power minus z. Okay, so we are taking 1 plus e power minus z whole power minus 2 into minus e power minus z. Now it has become, anyway it is minus 2. So we have taken here minus term is here, minus term is here, so it will become as plus, positive. So it is positive, and power minus 2 means you can write it as 1 by 1 plus e power minus z whole square, you can write that, into e power z. So that e power z by 1 plus e power minus z whole square. So that This we are taking directly here. So how it has become, that is, this is the small derivative explanation. To understand this, you should have minimum knowledge of the derivatives concept. Now, once if we have done this, then let us continue this derivative. Now, this can be written as, actually there is a square. So we are separating that 1 plus e power minus z, 1 plus e power minus z. We are separating this 1 by 1 plus e power minus g, e power z minus z by 1 plus e power minus z. Now, if you take this, in this, here we can take that this can be 1 minus, this can be represented with the mathematical formulas 1 minus 1 by 1 plus e power minus z. You just calculate this with the cross multiplication and all, so that you will get this again. We are writing this term as 1 minus 1 by 1 plus e power minus z. Now how we can write is, this is 1 by 1 plus e power minus z. What is this term? It is y actually. So y into 1 minus, this is also y. This is also y, 1 minus y. So in this way, the dou y by dou z value is y minus 1 minus y. So this is what we have done. Only this part we have done. What is our main aim? Our main aim is dou e by dou w. This is our main aim. So for that we have to go with one more step. Now I am calculating dou y by dou w. I want to calculate dou y by dou w. This I am calculating. Y, derivative of y with respect to w. Already we know dou y by dou z. So how we can use this? By using the chain rule again. Dou y by dou w k equal to, because of this sequence, x, w, z, y and e, dou y by dou z, dou y by dou z, dou y by dou z into dou z by dou w k, dou z by dou w k. So that already dou y by dou z we have calculated. What is that? That is y minus y into 1 minus y. That already we have calculated. Dou z by dou w k, dou z by dou w k, this already we have given this here. So we have to apply these two. Dou z by dou w k, this is xk, and dou y by dou z, this is this formula. And now we have the dou y by dou wk. Now what is our aim? Our aim is dou e by dou w. Now we are calculating dou e by dou w from here, from e to w. In between we have z and y. So how we can calculate dou e by dou w k equal to sigma dou e by dou y, dou e by dou y, just previous one, dou e by dou y into dou y by dou wk, dou e by dou yi into dou yi by dou wk. Now we can substitute dou y by dou wk, already we have calculated. For that we got yk, already it is there, and y minus 1 minus y, it is also there. Now dou e by dou y, dou e by dou y, it is ti minus t minus y, because there is a square. There is a square. Actually, a sigma, already we have the sigma 1 by 2, actually 1 by 2 sigma t minus y square. Actually, because of this derivative, this 2 and this 2 will be cancelled and t minus y will be remaining, so that the dou e by dou wk is this one. Right? Now derivative, that is delta wk, for the sigmoidal neuron is sigma epsilon. We have to multiply this derivative with learning rate. Learning rate into, we can give this entire option, entire term. So xk y into 1 minus y into t minus y. How it has come? You have to go through all these derivatives so that you will get. So this is the gradient for the sigmoidal neuron. Thank you.